I'm going to import another library here at the top that is going to be useful. It's called Seaborn. Okay. And let's explore with Seaborn very quickly because we don't have much time. I call Seaborn SNS. And what I'm going to do is a pair plot of only the first well. I would like to do a pair plot of the variables of the first well to see how they look like. Okay. So let's filter that, df, and I would like to get a data frame where the value is equal to this well, but I know that this well is in well names, is the first well of a list well names, so I can extract it from here very quickly, and let's see how that works. That's going to take a bit of time, and but that will produce a correlation, a cross plot across all the variables with a distribution, with a histogram of every particular variable. So far, so good. Any questions? Oh, sorry, I see that the chat is, I didn't see that the chat is, thank you, Yasir, for that. Yes, the unit of measurement. Thank you, Franklin. Okay. We're gonna get there, Hessian, with the linear model. That's the plan. So what we have here is the distribution of a tubing head pressure, the bottom hole temperature, and all the variables. The diagonal, it's pretty much a distribution of this variable. And what you see here, it's a cross plot. So for instance, if you see here, you can see the DP tubing, the DP tubing plot versus the tubing head temperature. Actually, let's see some of the ones that we have here at the bottom. We see here, this is gas volume versus the DP tubing. And so we have some other like gas volumes versus tubing head temperature. And we can see the distribution. You can see the choke size percentage versus tubing head temperature here. And we can start to, as part of understanding what kind of models we can use, we can start to analyze if we have a very strong correlation between variables, or we have something that may indicate that we have a non-linearity between models, and it may indicate that we may need different machine learning model, and we will tackle that later in a moment. Okay. Okay, so we have that, and okay. So the next thing that we're going to do, let's do a bit of an interactive plot to understand more the potential outliers here. Okay, and I'm going to use something called IPy widget. So IPy widgets, import interact. And this will allow me to do a quick interactive plot. And let's say for the beginning, we're going to define a function where I would like to do a box plot, box and a distribution plot. So we have box and distribution plot. And what I would like to pass here is a well name. So this function should produce something like, first of all, it needs to filter the data, right? And so I'm going to take some temporary data based on the data frame that we have above. And we're going to filter with the name of the well. So this is equal to this well. And then also the other thing that we're going to do here is I'm going to drop in the function, I'm going to drop my a couple of things here because I won't be able to do a distribution plot and a box plot of the dates and the well name column, because it's a category. Okay, so this is axis equal 1. So I would like to do that, and I'm going to add a couple of subplots. So let me add quickly the subplots. I'm going to use matplotlib. Let's use matplotlib. I'm going to import here the top matplotlib. Import matplotlib. Okay. And what I'm going to do is produce several subplots with the amount of columns. For every one of the variables, I'm going to produce a couple of plots. One is going to be a distribution of a variable, which is what you see here. And the other is going to be a box plot that will tell us the range and if we have any outliers on that data. So all this is very important on the as exploratory phase for the data before you feed into the machine learning model any spurious information. Okay. So we're going to take estimate the number of columns here, and that's for the row, and we're going to add 2 columns. So for every variable in there, we're going to add 1 row, and we're going to have 2 columns. And the figure size, just to make sure that we have something that can be seen, figure size, it can be 20 by 40. Okay. Okay, now just let me do this quickly here. I'm going to iterate over every one of the variables, every one of the columns here. And what we would like to do is produce these 2 plots. So the first plot is going to be using Seaborn. I'm going to use a box plot. See, a box plot. So I'm going to use this. This is the name of this is going to be the name of a variable. Let's call it this is a column name, call name, or variable name, or feature name. So I'm going to produce a box plot of that feature name, and I would like to put it on. My first column. So next I'm going to do the same. So first is going to be the box plot, and I'm going to do also a distribution plot. So distribution plot, column name, but I'm going to put it in the first column, and this is in the second column. So if I run that, well name, is that okay? Here. So if I do that, and I call this function, and I pass here well names, and I pass the first well. Let's see what happened there. Oh, no, this function will I'm missing here a square bracket. No, that's fine. Add. Name dates. Access. Call name. Start me. Let me see which variables if I'm missing one variable here that I shouldn't have. So we have dates, well named, bottom hole pressure, which has values, bottom hole temperature, DP tubing head temperature, choke size percentage, oil volume, gas volume, and water volume. So all those should have values. And in fact, if I do a df.describe, I have all those with values. I drop here, oh, df drop, I'm missing this. I'm dropping, but I'm not storing the results of a drop in the variable. Okay, so if I do that, and I'm passing the first well, you can see that I have the distribution of the property, in this case, bottom hole pressure. You can see that the bottom hole pressure, almost a minimum value, goes from 200. There are, as we can see, we have seen some outliers, which is when we shot, the well is shot. So there are some values with 0, which is fine. We'll clean that. Let's clean these values later on. And let's clean also any values where we have oil production here. So we have some oil volume outliers here as well. So generally the well can produce this amount of volume per month, but there are some some days that are producing outside the usual range of production of that well. So exceeding the expectation, I would say, or exceeding the range of production. Okay, so okay, we have a couple of there, and actually, that's with this. This should be the. Okay, now what I wanted to do here is to put a bit of interaction on this plot, so we can explore a bit more. So we're going to use interact, and we're going to say that the well is equal to well names here. And let's see what happens there. So now I have a drop down option here. I'm going to remove the one below, and I can change the well name. So we're going to take for machine learning later on these two wells. So I can change the value here, and let's explore it a bit. It's probably not a great idea to put, oh yeah, there we see. So you see in this particular well, we have many more outliers. So if we fit a model here, it might be a bit of a more problematic model to fit. A bottom hole temperature has a very small range of values here, and it has a lot of outliers as well, and DP tubing. So we have to be careful of what data we fit into the model that we're going to use later on. Same for tubing head pressure. Right. So we did that. I'm going to remove this one. We don't need that anymore because now we have a drop down. We can explore the data with this drop down. Let's assume that we explore all that data. And I'm going to do another step here just in one go. And this is to show you the production data between wells. And what we have here is in the same plot, I'm plotting two variables, the bottom hole pressure, which is here in blue. And we have in the black marker, we have in the axis, we have the oil production of a well. So we can see for this well, for instance, that we have shut down here. And when we see the build up of a well and so on. So if we switch to another well, we can see that it's quite different to that well. So not so many shut-ins. We have perhaps here we have just a reduction on the production rate, but it's not really a shut-in. So it's going to be interesting to see if we can train a model with which couple of wells. And we have this one completely different. This actually the gauge failed completely. So this is an interesting one to see if we can use the the machine learning model to continue predicting the bottom hole pressure of a well with the rest of the information. So I guess that you can see that the data is quite different. And we have also, I put some other things here, like the choke percentage per well. You can see that the choke percentage actually quite different on a well by well basis. And in this well, the choke percentage seems to be going down and down up to is that percentage? I think percentage is a choke percentage of closure. So this is completely open, I would guess. That's what it means. So it's almost zero, which means that the well is probably completely open at that point. So we have, this is a bit of an interactive plot that has a couple of axes here for the volume oil production and for the choke size, the percentage size, and so on. So that's good. So we have still more to do before we hit machine learning. So let's try to do that. So let's do further data cleaning. So we still need to do more data cleaning. And what we're going to do here, it's I'm going to get rid of all the zero values. So in this case, my model is going to be predictive only for my model will be predictive only while the well is open. Okay, you can almost think about doing another model for the well is shut. Although I wouldn't recommend to produce a model, and this is where the subject matter expertise come into play while setting up these machine learning models. We know that, and we can come from the slide here, that if we shut the well, most of the shutting behavior will be driven by the reservoir conditions. So this is during shutting. This is what is going to be driving the mainly probably the bottom hole pressure. So, but we don't have anything from the information from the tubing head pressure or from the choke size. We don't have that information. Obviously, we're going to lose all the oil production. So we are going to build a model just for the flowing bottom hole pressure, if that makes sense. Yes. So for this, of course, we can do a well test analysis, or we can produce it with a Darcy, or we can take the reservoir properties and try to fit a model with the reservoir properties plus some other conditions of a well, if that makes sense. So and that is a part of a role of a subject matter expert while building these particular models. We have Franklin connected. Franklin, I don't know if you connected at the beginning, but as I mentioned at the beginning, this model was built with Franklin Gonzalez. And thanks for, I see that you're replying there on the chat. Thank you very much. Yeah, by the way, you can interrupt me at any time if I'm saying something silly here, Franklin. Right. Okay. So let's do something more here, which is clean and filter the information just when the well is producing. So I'm going to apply a couple of filters here. So for the first filter, just to make sure, I'm going to set my oil volume has to be always greater than 0. And I'm going to add another filter in the data. I have to make sure that my bottom hole pressure is also positive. So I'm going to use just the data that, especially for the training later on, this is the data that I want to use. I want to train my model for with a bottom hole pressure positive, assuming that the gauge is not failing and it's actually measuring something. Okay. So we do that, we clean the data, and now if you can see the shape, we are reducing a bit further the information. Yeah, so we have a bit of less amount of